All right. Welcome, everyone. I am Anna-Chiara Bellini. I'm a product manager on Jetpack Compose.
I'm Clara. I'm one of the tech leads in Jetpack Compose.
And today, we're here to talk to you about Jetpack Compose. The first question is, what is Jetpack Compose? I have a definition here. So Compose is Android's modern toolkit for building native UIs. And I have highlighted 4 words there. First of all, it accelerates UI development, lets you write less code, using powerful tools, and an intuitive Kotlin API. Now, I'm going to expand on these 4 except one, because I don't think I need to convince anyone in this audience that in Kotlin, you write less code than with other languages, right? So we'll just skip on this one. But before we get started, one thing that is important. Compose is still in a developer preview, which means everything is in flux, everything is changing. It's a great time to give us feedback and help us shape the future of the product, but everything might change. So why are we even building a new UI toolkit for Android? We do have one, right? So the reason is simple. The UI toolkit has a very long history. It's been around for over 10 years. And in 10 years, things have changed. One of the things that changed is that devices 10 years ago looked like this. The UI you would put on a device like this is very different from the one that you have on a smartphone. Also, in these 10 years, the expectations of your end users have changed. They expect to see different UIs. There's another important thing that has changed, is how developers work, how developers think, and the things that they expect from a language and the tools that they use. There's actually another reason. In 10 years, we have written a lot of code. And the Vue.java is the class that every component that you see in an Android UI extends from, and it's a bit big. I took the screenshot this morning, and GitHub complains that it can't show me the file because it's too big. The reason is that this file is 30,000 lines of code. Obviously, in time, we have built some API regrets, but it's hard for us to step back and fix them or evolve the API without breaking other things that are around. So a good time for a fresh start. Now, on accelerating development, as you build apps, you want to focus on your app, and you want to have powerful components that will help you build this app. Now, let me give you an example. This is a simple text field. You just want to input from your user. It's not simple at all. It has animations, changes color, reacts to state. So we are doing this for you. So we really want you to have powerful components. We have material components out of the box with all of these beautiful animations. We also know something else. We know that a UI toolkit without the right tools is useless to you. It's not a good experience for you. That's why even if Compose is still in very early stage, we started from the very beginning working with the Android Studio team to make sure that as we build Compose, we also build the tools that you guys will need to use it. Well, let me give you an example. So here is the Compose preview. This is a feature in Android Studio that is available in the Canary versions of Studio, and it's been built specifically for Compose. So as we build this checkbox button, as you develop it, you can see how it will render when it's checked, unchecked, on a light theme, on a dark theme. This is just the beginning. We're obviously going to add many more tools as we keep working on this. Now, let's get back to the Kotlin API. This is the core of our talk. We want to build the API that is good for you more than for us, right? So how do we go about this? First of all, we're developing in the open. It's not only open source. All of Android is open source. But in particular, this one is being developed daily in the open. Our engineers, day-to-day, push their code to the Compose source. You can check it out. You can see how the project is going, where it's heading, what our engineers are doing, which also means you can give us feedback. And this is really helpful feedback. It helps us understand what is working for you and what doesn't. There is something else that we do. As we tinker with our API, we test out different options, what would work best and what not. We build prototypes. And then we work with our user experience research team to make sure that we get the right feedback. So they test out these prototypes with users, and they give us feedback. Some things actually make it into the product, others don't. Let's go a bit more on the technical side. So Compose project structure. On the right-hand side, in green, you see what happens at runtime. I'm not going to touch on that because Clara is going to talk about it. But what happens on the left-hand side? Left-hand side, build time, we have three important parts, and I'm going to focus on the Compose compiler plugin. That's where the magic happens. That's where, under the hood, all the wiring of your declarative UI happens. It is important to understand that this plugin is built on top of some compiler extensions. And these compiler extensions, we built them, but we're working very closely with JetBrains so that it doesn't happen at some point that we diverge or we fork, and you find yourselves in a situation where the Kotlin compiler on Compose is different than the official one. You will always be working on an official Kotlin compiler. And if you're interested in a compiler plugin, tomorrow there's a great talk by Leland Richardson that just goes deep dive into it. Last but not least, why is it even in Kotlin at all? Well, we have several good reasons. The main one is that about a year and a half ago, we decided with Android, we announced that we were going Kotlin-first. And at that time, obviously, the adoption of Kotlin in the Android community was not really strong. But we knew we had a long time frame. We knew it would take us time to build this toolkit, right? So what we did is we went all in on Kotlin because we knew that by the time we released it, the community would have caught up. There are also some technical reasons. Obviously, building a compiler plugin is available in Kotlin, not with other systems. And the thing that probably we like most is that the features of the Kotlin language are allowing us to build a very nice API, and that's what Clara is going to talk about.
Thank you. So let's talk a bit about API design. Like, we're building this entire new system, and we need to be very careful of the APIs that we build for it. We have a history of API design in Android, right? Like, we've built a system for the last 10 years. We have a team of people who review APIs, who try and come up, like, what are the guidelines? What are the ways that we should be exposing API on Android? But there's a catch. We've been doing Java programming language for the last 10 years. So we have a lot of guidelines, but now we're starting to explore a new world, right? We're trying to come up with what are the Kotlin guidelines that we should be exposing. And in this sense, Compose is the first large-scale project that we're embarking that is purely Kotlin. So in a way, it's kind of spearheading our API design for Android overall. So we're trying to come up with some Kotlin API guidelines for Android. And along the way, turns out there's a huge overlap in teams. We're trying to figure out, like, how does that apply to Compose? So what parts are Kotlin API guidelines that we're going to give to everyone, and what is, like, very Compose-specific that we want to work on? Obviously, all of this is work in progress. Compose is not shipped and nowhere near being shipped. So we're still working on all of this. But I want to talk through some of these points today with you. So let's look at API design in Compose. We have several principles that shape how Compose is built as a system that are very core to what we do. And talking to the team, it doesn't surprise us anymore because we've been working on this for a while, but they are the core essence that we need to explain to someone new on the system. The first one is, in Compose, everything is a function. What does that mean? Well, you have functions that call other functions and eventually emit pieces of code. So you build your UI by just creating this hierarchy of functions that call each other. We are a declarative system. If you're not familiar with declarative systems, the root of it is there's a UI tree that gets defined. So you describe what you would like your UI tree to be. When the state changes, you describe it all again, and you let the engine figure out what changed and what parts of the UI need to update. In Compose, our UI tree is actually the function call graph. So every function is a node, and we figure out, and that's why we make heavy use of the Kotlin compiler plugin to figure out, like, what code is calling where and what that graph looks like. So say, for example, one of your functions has an if statement. That tells us that that graph may change. And at some point, you may add a new node because you're calling a new function based on a state change. The basic building block of Compose is a composable function. And a composable function is just a function that has this @composable annotation. This is used by the compiler in the runtime to figure out. And a composable function is only called from other composable functions. It's kind of similar to how suspend functions work. So we create this entire hierarchy of calls calling each other. You can only call a composable function from within another because that's how we built the UI tree. Obviously, we need an entry point. So we've created some convenience methods. There's set content on activity that will throw you into a composition context so you can start your compose for the entire activity. We have other ways of composing just a piece of your UI if that's what you're looking for. In Compose, not only everything is a function, but everything is a top-level function. So actually, we've stopped using classes. So we have a ton of new high-level, top-level functions. And this is very useful for us, because usually we want a composable function to always produce the same UI given an input. By giving up on the class structure, you can't access any variables that are in your class, so you can't cheat. Like, you can only take the input that you're given as a function and always emit a predictable UI based on that input. It does have, so this is a huge paradigm shift. I don't know if you realize. It has huge advantages. It has some tricky bits that we're still figuring out. So for example, if everything is a top-level function, your autocomplete turns out is not great, because everything is in your scope. So we're trying to figure out what are innovative ways that we can make sure we guide you to the correct API that you're looking for in this new world. Another important principle of Compose is we definitely prefer composition over inheritance. So we build things out of other pieces. We don't inherit behaviors. So if you're an Android developer, you'll be used to the Android view hierarchy. And there's a hierarchy of classes. And basically, anything that is a view on Android eventually is inheriting from view. So for example, the checkbox inherits from compound button that gives it a bunch of functionality, which inherits from view. And as you saw, Vue has a lot of features. In Compose, we've shifted this model completely, because everything is a top-level function. So things like toggleable, text, checkbox, they're their own functions. They exist as their own, and they compose other functions to create themselves instead of inheriting from a parent class. As I said, everything is a composable function. I want you to notice there's a huge paradigm here shift. If you're used to having to create custom views on Android, you have to inherit view and then do a bunch of custom handling of lifecycle and all sorts of other things. In Compose, creating a new view is just creating a function and adding an annotation, which is a huge change for us. Like, this means you can build very reusable UI. You can build small pieces of UI and really put them together, which is very different from what the previous system was doing. Another similar principle is feature composition. So I said you can build all these smaller pieces now. You can really reuse your logic. So instead of having tons of features, we prefer you create different composable units and then just put them together in new functions, because you can keep kind of putting all the pieces that you want into one functional unit. Looking at an example, this is from TextView, the existing Android TextView. It has a setIsSelectable method that turns on and off selection. This is the kind of thing I'm meaning. Like, we don't need to expose features as parameters into widgets anymore. We can just create a new composable that is a selectable text and just composes text and selection together, because these are two different entities. Another very, very important principle that we're basing the entire system on is that there's a single source of truth. If you're used to the existing Android Toolkit, you'll see there's things like, for example, checkbox. I pulled a method in here. When you tap on a checkbox, it has this perform click method. The first thing it does is it changes its internal state. It has this mChecked variable that it owns. And it's like, OK, I'm changing. I'm checked now. And then if it remembers to call you and make you deal with your thing. So as a developer, you have to listen to the checkbox, know that it's changed, go update your settings or whatever this was representing on the UI. If that fails, remember to go back to the checkbox and say, oh, actually, you need to uncheck yourself. So this is a huge source of bugs for our developers. Instead, in Compose, we kind of reversed that. So a composable function like checkbox usually takes two main parameters. There's a checked, which is just its state, like, am I currently checked or not? And an unchecked change lambda, which is just saying, when I'm checked, or when I'm tapped, basically, I will call this. But checkbox itself doesn't hold to any state of its own. So for example, if I pass in a true, and then I pass in a lambda that updates my source of truth to something else, like false, when that lambda gets called, when that value gets updated, the system will figure out that the source of truth has changed and come in and recompose this checkbox and say, oh, actually, your value is now false. So it's a change in the dynamic. Instead of the checkbox changing first and then us having to update our values, we're updating our values first and letting the checkbox figure out that the source of truth has changed. This kind of is very, very tightly related to another principle that is very important, which is properties go down and events go up. To be able to do the single source of truth, as you saw, we had two things in checkbox. So say I've implemented a settings screen that is very simple. It has a label and a checkbox. The important thing is I will tie in the checked variable to some source of truth. I may have some kind of setting store that is storing what my settings actually are. And I'll tie it to that value. And then in the Lambda, I'll update that value. And that operation doesn't need to be synchronous. Maybe I'm doing a server call that says, please change this setting. The checkbox will not change value until that comes back and is very important, changes. At that point, Compose will figure out that the data has changed and ask this checkbox to update. This pattern is very powerful, and we want to definitely encourage everyone to build components in Compose like this. We call this a controlled component. It is basically a single unit of functionality that doesn't need to own its own state. So you're giving it the state it needs to be, and you're giving it what to do when something happens. But you are controlling its state. It's a very powerful pattern because it allows us to really do proper state handling across the system. However, there's more complicated cases. You'll be like, OK, checkbox, very easy. Let's go into something a bit more complex. So for example, if we had a scrolling component, so you want to just be able to pan through your screen, well, scrolling has a scrolling position, right? And that's a state that you would consider, well, the scroller usually owns its own position. But I just told you we need to apply this pattern, so you'll add the scrolling position and some kind of lambda to call back when the scrolling changes. Suddenly, you've punted a bunch of logic on the developer, right? Like suddenly the developer using the scroller needs to handle this and update the scrolling position when the lambda gets called and kind of own this state. So we take the pattern a bit further and we say, OK, there are these sort of components that we still want to let you control, but there is a very good default behavior that we want to give you out of the box and let you do. So we do something like this. We can create a class that is a scroller position, let that class have the methods for updating position, maybe animations, implementations in there, and then we provide a default value. Which this means is that this is still a controlled component. If you want control over the scrolling position, you can take over. But we're providing a default implementation for you to make sure it's easy, because sometimes you literally just want your screen to scroll, and you don't want to have to deal with everything else. And this is a very important principle for us, and it's kind of at the heart of everything. Suddenly, everyone is a library developer. And this is very important to us, because we're used to being kind of on the other side of the fence. Like, we're library developers. We provide components for other people to use. But we're very excited that with Compose, we're opening the doors to everyone being a library developer. Creating new views and creating new behaviors and being able to reuse them is just creating a function. So suddenly, we're opening the door to a lot more people being able to use all of these reusable pieces. You may publish a library. Maybe it's an internal library to your app. But still, it enables you to think, like, oh, this is a reusable part of my logic that I want to be able to reuse in other pieces. And it's not tied to that inheriting of view.java that you had before. Say, for example, I've pulled here the implementation of our button. I've simplified very little in this slide, I promise. A button really is just 4 different other composables that we put together. There's a thing we call a surface, and this is just the canvas with its background color and maybe the shape around its corners and that sort of thing. There's a ripple, because when you touch on the button, we want it to animate nicely. We have a clickable, and I'll go into more detail into the layers later, but a clickable is just all of the gestures and the accessibility bits that we need to put together a button. And finally, there's a container that holds on to what's inside the button. You can see that we've just put 4 functions calling each other in a hierarchy, and suddenly we have a button. Because everyone's a library developer, you can decide you're going to create my custom button and just take what we did, which is a very simple piece of code, and maybe you're going to swap your surface for your own surface that does, I don't know, squiggly borders or something. It's very easy to take pieces that we've built, put them all together, and make your own thing and ship that as a new component. Now that we've looked at the principles, we were kind of figuring out what would the best talk for this conference be. And we figured, obviously, we had to talk about how we powerfully use Kotlin within Compose. The first thing that we want to point out is we follow the Kotlin-style guidelines, but we do have some nits, maybe, that make our system more readable. The first one is every composable function, we always make it a noun. And that's because we think it represents an entity, a piece of thing that produces UI. So it is a thing. It's not an adjective. It's not an adverb. It's a piece of UI that it's representing. So we always make them nouns. There's things like top app bar, text, checkbox. These are all kind of familiar names, so this shouldn't be surprising to anyone. The next one is this is sometimes controversial. We uppercase, we Pascal case composable functions. This seems surprising to some people at first, but we want to point out this is already an existing pattern. So in Kotlin, there's an exception where constructors, so extension functions that are used as constructors can actually start with an uppercase letter when it's exactly the name of the thing they're constructing. This is kind of the same. We are building a piece of UI. I want to point out, like job and coroutines does this. So we kind of followed the same pattern. The main difference here is that usually in the exception that Kotlin allows, you're actually getting an object back that represents exactly that name. In our case, you're not getting anything back. You cannot hold onto a composable. That's the whole point. But you are building something, so we wanted to follow this pattern. The main reason why we follow this is because it improves our readability enormously. So say I've pulled out, this is an unedited piece of code out of one of our samples. And there's quite a lot going on. But suddenly, if you look at the uppercasing, you found all the composable functions. It's very easy to read. It makes it really easy to spot what's going on. Another interesting thing that Kotlin has really given us is the trailing lambda syntax. It's used heavily in DSLs, but we've used it very, very heavily to create the structure of our UI. So we really use the trailing lambda syntax. If we go back to the example we were just looking at, there's a column. And a column, what it does is just place things one above the other. And suddenly, it's very easy to spot what is in that column. Well, everything in its lambda. So it's very easy to see the structure of our UI in that way. And it obviously goes recursively. So then there's a row, which is a horizontal layout of things. And then we can see what's inside the row. Well, the things inside of one level of indentation in. So it really helps us provide this UI structure that makes it very readable. One of the features of Kotlin that we're really using out is default values. This is something we couldn't do before. So if you look at our APIs in the toolkit, we have tons of overloads for different things. Well, in Compose, we've managed to get rid of all of that because we can provide default values. Say something like a bottom map bar. It has a lot of different parameters. And you want to be able to customize all of them, because developers always want to customize everything. But we can't force you to specify 40 different parameters. But by heavily using default values, we're finding a lot of use in that we can expose the parameters that we want you as non-default values and just fill in all the others with reasonable defaults. And finally, this is a favorite part of the team. We've managed to strongly type our units. So Android has a history of like loosely typed units. Well, we've done something. This is an example I pulled out of text. We can now define a text unit as a class and actually define extension functions to int so that we can define our units, which is much nicer than having to wrap all our units in different functions. The way this looks like in usage is something like this. So when you define a text element, you can define its font size by saying 14.sp. And suddenly things work. It simplifies our API because that one same API works if you want to say 2.em. Same thing. So it's really simplified the amount of overloads, the amount of units we need to take. Let's look now at further deeper. I've been talking like very abstract terms here and very big things. Let's talk about how we've applied a lot of the principles to the project. You've seen this diagram before, and Anna-Chiara promised I would talk about one of the sides. So let's focus. We have a runtime, and above that, we have three major layers that we're building. It's what we're calling the UI Toolkit. At the bottom of it, we have a layer called core. This is the core of the system, as the name kind of implies. And it's what you need to do like very custom things. It's the real like engine of the toolkit in there. Core has four main pieces. Draw, which gives you access to a canvas. So it's a composable that literally just gives you a canvas parameter, and you can do all of your custom drawing. We have layout, which gives you all of the tools you need to measure and place things on the screen. We have input, which gives you all of the different motion events so that you can actually handle gestures. And then we have semantics, which is what we call the semantic information of your tree, because you can define what something is, and suddenly it's not only useful for accessibility, it's useful for things like testing as well, or maybe autofill needs to know what's on the screen. So these are our four basic building blocks. We don't expect most people to have to go down to this level of API. This is kind of the core of the system. We're obviously layering things on top to make it more easy. So the next layer we call foundation. And the core of foundation is really to take all of the different pieces that I just showed you and build higher level abstractions that are actually usable for our developers. An example here, I showed earlier that a button is made out of a surface, a ripple, a clickable, a container. Well, clickable and container belong to the foundation layer. There are two pieces that are taking Containers taking the layout tag and actually building a specific layout for things. Clickable is taking the input of clicking and actually making a gesture out of it, and then adding all the semantics of what that means so that we can use it for testing and accessibility. And finally, we're building a top layer. This I'm very proud of. We're building the material design system. If you've seen Material before, it's a design system that is widely used on Android, so many of our apps use it. And it provides all of the componentry that you need to build an app, things like the top app bar, buttons, checkboxes, that sort of thing. In the Material layer, we're providing all of these APIs. So if you look again at the example of button, the top 3 that I emitted earlier, these belong to the Material layer. You may ask why. Well, ripple is actually a material design concept. So the fact that when you touch, there's this little circle that expands, that's actually material design who made that. Surface is the concept of a canvas where those ripples happen. And then finally, button is our high-level API that just gives you a button that uses all of the material design system. Defining all of the material APIs brought us to a very interesting pattern that we wanted to talk about today, which we're calling slot APIs. Slot APIs are what we call when we leave a gap in the UI so that you can fill it for us. Say I've been talking about button and how button exists as an API. Most developers just want to give us a string and be like, just render this. And we can do that. We can have an API that is just button, takes a text, it's a string. It displays it in what looks like a very material button with like a background color, which is the primary color, the rounded corners, the all caps text. But sometimes developers really want to do custom things. So for example, you may want to put an icon and a text. And suddenly we have to start complicating our API by adding an icon parameter. Then suddenly you'll be like, oh, but I want to customize the spacing between the icon and the text. And suddenly we have to add another parameter. And this creates parameter explosion. So it really makes our APIs a lot more difficult for most of the people who are using them. And it turns out we never foresee correctly what people want to do. Like, we can try and guess all the customizations, and we're always surprised when we talk to developers. So we've been here before. If you're familiar with text view compound drawables, this is sort of that thing. We do not want to make that mistake again. So this is where we enable the slot APIs. The core principle of slot API is I literally leave a gap in my UI. And because composables are just made out of functions, we can take a function from you in a Lambda and just place it there. So this is very useful. For example, for button, we just take a trailing Lambda, and we fill it with whatever we want. If we want to recreate the example before, and we haven't provided this functionality for you, well, you can fill it with a row, with an icon, a bit of space, and some text. And suddenly you have control of what goes in there. And we don't have to bother with trying to guess what you're trying to do. So as you saw, a button has this API that is the slot API, which takes a children, we always call them children lambdas, because it's kind of child UI that's going to be emitted into the hierarchy. And that enables you to do the slot API. So we end up with 2 different APIs. I've said there's a button that takes a text as a string, and a button that takes a lambda, which is a children lambda, that allows you to do whatever you want with the space inside the button. We do this with more complex components as well, so button is kind of an easy example to explain. But for example, material has a top app bar, and you can see there's like 3 sections in a top app bar. There's this navigation icon, then there's a title, and then there's a bunch of actions. Well, again, we can try and guess everything you want to do, or we can just provide 3 slots and let you give us what you want to put in there. This enables interesting things, like maybe you want your title to be 2 lines long, and we didn't think of that. Or maybe you want to have a little column in the title that has a title and then a subtitle with a different style. Like, because we have slots, you can suddenly customize all of those pieces of UI. But this brings us to a very, very interesting API challenge, which we're calling the single-child composable problem. Let me go back to the example we were showing. We have a button, and I very sneakily did the right thing because I had entered a row with things. But what happens if I just put 2 text elements in there? What do you expect to happen? Because you're not telling me how you want these 2 elements to be placed. Do they go next to each other? Do they go on top of each other? We don't know. The same happens for a lot of the layout components. So for example, we have spacing. And spacing represents the space that you place around a component, similar to padding or margin. If you do a spacing around a text, we know what to do. What if you put a spacing around 2 texts? Like, OK, no idea what you're trying to do here. Are you trying to place space around both texts? Or are you trying to place space around each of the texts? It's an ambiguous problem, right? Like, we don't really know your intention. And this is where we came up with a solution called Modifiers. And what modifiers are is taking these behaviors and making them functions instead. So taking back to our example of a spacing with 2 texts, instead of doing this, we replace a spacing with a row. And a row tells us how to place these 2 items. And the spacing has become a modifier. And modifiers are just these functions that enable, right now, just layout modifications, but enable you to do certain operations on the layout nodes that are below. But it's very clear that suddenly the intention is very straightforward. You're trying to add spacing to the row. So then this is what I expect to happen. And now suddenly the system can interpret what you're trying to say. We have a bunch of different modifiers implemented at the moment. Things like sizing, aligning, like the things you know as gravity, like all of this can become modifiers. Because they're things that otherwise would only take one child as a composable. We can make them into functions. But there's still a lot of things that we're working out. As I said, this is a project that is very work in progress. We're trying to figure out what the best usability of our APIs are, and we don't necessarily get everything right or agree on answers to everything. So for example, I moved away from the button example with the 2 texts, and I told you that we solved that for layout. So I said modifiers work for layout and things like spacing. I didn't talk about button. What do we do with the 2 texts? Oh, sorry. The 2 texts are ambiguous, and so we need to provide something. If we leave it as this, as it is right now, this would provide a crash, because we wouldn't know what to do, and that's a very bad developer experience. The thing we're trying to decide to do now, and we're kind of agreeing on, is for now, while we don't have a better solution like modifiers, because we can't apply modifiers to this, is provide a default. So every time we emit a slot, make sure we provide what the default behavior of that slot is. So maybe in the case of button, the natural thing is to place things next to each other. So we'll make sure that inside there's a row to grasp into everything you put in the slot, and at least we won't crash. But it's still not necessarily nice, because we're adding an extra layout node in there that maybe you don't need. So we want to make sure we find a proper solution for this. The other one I wanted to point out, I've shown you these 2 APIs before. We have a button with a text string and a button with a children composable. But there's an interesting dynamic between both of them. If I have a button that is using the slot API and I have some text inside of it, and then suddenly I add text as a parameter, the meaning of that lambda changes if I leave my on-click listener in the first API as the last thing. So going back to the APIs, I was very sneaky in that in the first one, the click handler for the button is not the last parameter. Notice how there's an on-click, and then there's something else. And this is because right now, if we want to use the trailing lambda to really mean structure in Compose, we have to decide what we do with trailing lambdas that are not structure. Like, do we leave them in? Do we allow you to have an on-click listener be the lambda at the end? Or do we have to hide them always and move something else to the last parameter to avoid you getting into confusing places? Oh, sorry. Like that one, where suddenly the meaning of the trailing lambda may change depending on the parameters you've provided. So this is still not something we agree on necessarily. There's a very, very long road ahead of us. I've barely touched on some of the things that have kept the team busy over the last few months. But Compose is definitely still a developer preview. We're really working through this. We really care about the UX around our APIs. And we're working, as Anna-Chiara said, with a bunch of UX research to make sure we get it right. But it will take a lot of months to get there.
Thank you. So last thing, how do you try it? I mentioned before that you can check out the code. That's not necessarily the easiest way to try it. That's more if you're interested in how we're developing Compose and how to contribute eventually to Compose. But if you just want to try it out and see how it feels as an Android developer to build with Compose, we have a few options for you. The first one is if you go to our website, the URL is there, very easy also to search for. This one points you to our tutorial, our samples, and our documentation. We have as well a code lab that takes you a bit deeper, guides you through all the steps from setting up your project to building a full component. Developer preview it went kind of silent. Almost nobody noticed that it was out there. But we basically built artifacts for you. Okay, so they're released on Maven, and you can just try it out. A couple of months ago, at the Android Developer Summit, we released Developer Preview 0.2, which was basically the first one that we announced. And we also released a bunch of samples. But very shiny new, just for KotlinConf, just last night, we released Developer Preview 0.3. So you can actually try it out, the latest and shiniest, without checking out the source code. All you have to do is download the most recent Canary build of Android Studio and create a project. That's going to be super nice. And obviously, if you do, please give us feedback. Let us know how that is feeling for you. Last but not least, tomorrow, as we mentioned, there is this talk by Leland Richardson. It's at 10:15 tomorrow. If you are curious about how the magic happens in the compiler plugin, please go to the talk. And that is all. Thank you so much.
Thank you.